So here's our big piece of alley. Picked it up today. Big variation in the cost of these. I think one place wanted $370. I got this for $220 from Ulrich Aluminium in Caloundra. They've always been really good on time. Measured up the space it's going to go in. Those are the dimensions there. Should give me about 135 litres all up. As I said before, this piece plus all the bends, joins and weld-ons, less than $300. So cost-wise, if it all works, it's going pretty well. Now typically when they make up a tank, they will use a press to fold it in as many places as they can, and it just saves on the welding. Less welding, less chances for there to be a pinhole leak, etc. So I'm going to do that, but I don't have a press, like a 90-degree hydraulic press to bend sheeting. So the way I'm going to use it's a bit untraditional. I have never seen it done, but I think it's going to work. If I just tried to bend this using clamps or my feet or whatever, it'd just make a huge mess of it. So I need to weaken it along the lines that I'm going to fold it along. Now what I do have is a really good circular saw and a metal cutting blade, and on this saw I can adjust the depth that the saw cuts at all the way up to 0. So what I'm going to do, I'm going to set it so I actually cut it where I want a mil and a half. This is why I got the thicker stuff, the 5 mil. And with that mil and a half extruded out of where I want, it should bend along those lines really well. That's my plan. Mark up all the bits, all the lines you're going to fold it at, all the other bits, the baffles, everything on it. That way you'll come up with the most efficient way to cut all your bits out of this and you won't have to go buy another sheet. So that's what I'm going to do now. So I've marked up all the lines that I'm now to cut and extrude on. To get these cuts really straight, even using a good circular saw, it still is pretty easy to sort of go off your cut line. So what I do is I get some other large elevated object that I have confirmed to be straight by doing a square test on the edge of this. It's an old bit of hardwood with a straight edge, and clamping it down. I know that for a fact this saw cuts 40 mil off whatever this right hand side of the saw is up against, so I can just run that all the way down there and I know it'll cut true. And that's what I'm going to do for all of them. So all the main bits are cut out now. Starting to move on to the extrusions that I'm doing. Done a couple of test ones just here. On my saw you set it up by just this pin here. You can adjust it there. So I've got it set right there at about 2 mil. It seems very accurate. I put it on 5 before and it's exactly 5. Now I've dialed it back to 2, which is exactly where it is, which is what I'm going to try the first one on. If it's looking a bit thin, I'll try and bring it back another 0.5 mil. But yeah, let's see how this goes. So that's the extrusions done. Had to do 2 passes of each one really. Often the saw would lift up a little bit and miss a section. Worked a lot better using the handle on the front of the saw, pulling it through rather than pushing it through. That's probably the only pointers I can give for that. Just going to tidy these little bits up with the angle grinder and see how it folds. Crude, yes. Dangerous, definitely, but it works. Same process for the bigger sides, just sort of have to do it half each side at a time. I'll try and do a slow motion or a time lapse of this one. So to do the final bit of the bend, I used 3 big ratchet straps. Definitely the best way to do it. Should have used them from the start. You can get everything really accurate. You can get it together and hold it together the corners. Now just pause it here for a second, because as you can see, I am MIG welding this. Mainly because I have a MIG. I'm not prepared to buy a TIG and I'm just not very good. So to counteract this, what I've done is made every corner have about 10 millimeters of overhang. The reason being is that with a MIG welder, it is far easier to weld an internal corner as opposed to an external corner. And I don't want to be welding internal corners in case there is a leak. I'd have to cut open the whole tank. You'll see later on I use the same technique on the lid. The lid overhangs the walls of the tank by about 10 mil everywhere. So all my welds are an internal corner, but on the outside of the tank. I'm up to the welding now. I'm not going to do a huge run through of how to set up your welder, correct ways to weld aluminium. Obviously, you're tidying up each of the corners with a wire brush and an angle grinder. It has to be a stainless steel wire brush before you put any weld onto it. Every weld is different, but I'm probably at about 3/4, both in terms of voltage and wire speed. For welding alloy, you have to have pure argon gas. Yeah, that's probably about it. So now we're going to do the baffles. So what these actually do, well, firstly they add strength. Secondly, which is their main use, is to stop slosh. So that's the motion of the fuel or whatever's in the tank moving side to side as the vehicle or the boat rolls in swell. And you can especially notice it when you're at rest in a slight swell, and it often adds to the rock of the boat. So that's what these things do. Again, just using the residual of my big piece of alley sheet. The tank it's about 15.5 centimeters deep. I'm only making the baffles 14. I don't want them to, under any circumstance, be touching the roof of the tank. Thought maybe if the tank was expanding, contracting, it could make some noise, it could cause wear. So I am making sure that they sit shy of the roof of the tank, and the walls and the floor will give enough strength to hold them up. So surely I don't have to reiterate it, but I'm going to anyway. You will need to cut the corners off all the baffles, because depending on where your pickup is, you will want all the fuel in the tank to be able to get to the lowest part of the tank. As for the quality of the welds, no one's ever going to see them, so as long as they're structurally sound and they didn't melt through, I don't really care. All the internal ones are pretty shocking, doesn't bother me. I did have left over just a few strips like this, which I tidied up and just added in here just to give it a bit more strength and hold the sides together a bit better. So today the first of the weld-on fittings for the tank arrived. They're all off the Aeroflow website under the fabrication section, except for this one. This one was in, I think, miscellaneous bits, and it's listed as a radiator bend, but I thought this would make a good weld-on fitting for the actual filler port, because it's the same size. The hose that will go in, that's the same size as what most fillers are. I'll run through the function of these as I actually put them onto the tank, which I'm going to do now. Used a 12mm drill bit, and I think it's a 30mm hole saw. Didn't really have something for that size, so I just drilled it with the drill bit and then sort of opened it up a bit with a burring tool. And yeah, that's where they're going to go on. When you weld on one of these threads, make sure you actually put the bung in, because often they deform a little bit as they heat up and weld, and you won't be able to get it in, or you might get a bit of weld on your thread and ruin your thread. So leave the bung in. That one's done now. Only one left to do is this one. Because the wall of this pipe is just so thin, I'm worried if I do on the outside, I'm just going to burn through it. So I'm actually going to try and do the whole weld more so on the fuel tank plate from the inside. So a final barb has arrived. It's just a 3/8 inch weld on, and that will actually be the fuel line to the motor. As you can see, I have drilled the hole. It's at the bottom of the tank. I'm not doing a pickup through the lid. A few reasons why. Just simplicity. I struggled to find a Fabrications product that would work to do that. And finally, I will be running a big inline fuel filter, so any crap that does end up in there will be filtered out. So this is the top of the tank that we're doing up now. The way it all worked out, it wasn't quite long enough, so I do have to weld two bits together. I picked two pre-cut surfaces, so the join's perfect. I'm still going to sand off each corner with the grinder to get a bit of a V and get sort of really good penetration down into that gap. Just a little comparison for you. Gas, ran out of gas. So here's the top of our tank. I welded up before, and I've just cleaned up the weld with the angle grinder. That turned out to be really strong. I tested it by standing on it, and it was probably as strong as the rest of the sheet. So now I'm going to put in the fuel sender. So this actually gives the fuel level to one of our instruments on the dash. Now this is a universal kit. Generally, they are all universal and they work on a 5-volt signal. They send 5 volts to the sender, and then given the level, it'll send a certain amount back, and your gauge will read that proportionally. Now, luckily, I think that's going to be the perfect size for our 32mm hole saw. We just got to work out exactly where through the top it's going to go. It just can't be in the way of any baffles. So my thinking is we put it about here. So you have to cut the sender length and the arm of the float to a certain size. It gives you all the details in a chart, and it all depends on how deep your tank is. Yeah, you just cut it down with the angle grinder. So it's a good idea to actually do a sanity check on these. And I had it wrong before. It goes off resistance, not voltage. So going off this, it tells you what resistance it should be where, and looking at this, it's the wrong way around, so I put this the wrong way around. So that's it, working properly now. It's a pretty neat little unit, really. That varies the ohmage, resistance rather. So to fit the fuel sender, again, drilled out another 30mm hole sorted out, and holes around the outside. This is actually the bottom, so I'll tidy it up with the grinder before I go it on, so none of those little bits fall down. So I'm about to weld the top on now. This is the most welding, so it's probably the most likely chance there's going to be a leak. This is actually the bottom. You can see I've tidied up both the edges of the base and this, so I've got a really good surface to go off. You just got to find the right settings on the welder and the right speed and stick with it all the way through. So the top tends to sag a little bit in the middle, so I'm pulling it together with a clamp and just tacking it in each spot before I run the full weld along. Just another little tip to make it go a bit better. So that's the top fully welded on. As for the welds, it's a bit of a mixed bag. Sometimes it'd go really, really well and the dimes would stack. Other times I had to go back and do a second weld that was too thin, or there was an obvious hole. I turned the ampage up probably a little bit higher than what they recommended. My thinking was it's just going to melt it together a lot better, and I think I'm less likely to get any pinhole leaks, even though I know there's going to be a few, especially in places like that. But the next step's going to be take it outside with a hose, fill it up, see where all the leaks are, which I know there will be leaks, mark where they are, come back, just repeat that. So this is the leak test. Filled it up with water, and who knew MIG welded aluminium has leaks. So what I'm doing is wherever I find a leak, like for instance I found one here, I'm actually drilling it out a bit, so it's going to expose more of the actual opening, and I'm going to come back and tack weld up all of these. It'll also mean that I won't lose track of where I found a leak, but it's mainly to expose fresh metal to get a good tack weld on. Right, so as you can see, I've sealed up all these little pinhole leaks that I drilled out and found, and I filled it up with water again. Now it's not dripping any water, but I'm still seeing moisture appear in a few spots, so that's where this stuff comes in. Even the professional guys use this. It's a fuel tank sealant, and I blew a huge hole in the front diff of my 4B once, and I welded it up and it was leaking, and I sealed it with that, and it's never leaked since. So this is really good stuff. You've got to wash it out with this first, get all the contaminants out. Now I did that last week, and you've got to let it completely dry. So it's been sitting here for a week and it's dried. I tried to dry it by putting my exhaust over that, thinking the hot air would dry it, but it just condensed and put a lot more moisture in it, so I pretty much had to leave it for a week. So don't do that. So with it all mixed up, probably going to pour about half of it into the tank and rotate it round. I'm going to try and do a bit of a time lapse of what I'm doing. Sort of giving it 2 whole cycles all the way around, and I'm still seeing it coming out here, which is good. So it has spread around all the welds, which is what we want. Just beware of dirt and grass. Probably should have done it on concrete. So giving all the sides a good clean with some wax and grease remover. I'm actually going to paint an exterior coat on, so I've got a seal on both sides. So I left the sealant inside and out to dry for 24 hours. I've just put 20 litres of fuel in it, leaned it onto every side, and we've got no leaks at all. Not even a weep, not even a bit of moisture appearing. I'm probably going to do one more coat of the remainder of the KBS just in case, but no, that's it done. As I said before, this would have been a lot easier if you were a good welder or had a TIG welder. You wouldn't have got any of the leaks and your welds would have looked a lot better. But all up, I think it was about 290 bucks, maybe 300 bucks I spent on all the bits. So a lot less than about 1200 than what a shop wanted. Anyway, that's it for this episode. Thanks for watching.